Just like we have different types of animals that belong to one group, we have different matrices that come under the blanket of matrices. In our previous video, we played around with a few different types of matrices. One of those was a square matrix. A square matrix has an equal number of rows and columns, which makes it look like a square. Even this little matrix that has one row and one column is a square matrix. The only difference between this little square matrix and other square matrices is the lack of diagonals. Square matrices that have more rows and columns will always have two diagonals. One diagonal includes elements from the top left to the bottom right of the matrix, and the second one includes elements from the top right to the bottom left. The diagonal going from the top left to the bottom right is called the principal diagonal, having these entries, whereas this other diagonal is called secondary diagonal. But it's the principal diagonal that's the real deal. Whenever we talk about a diagonal of a matrix, we'll consider the principal diagonal. You can also call it the main or leading diagonal. Let's look at a couple of square matrices. The first thing you'll notice is how the principal diagonals of all these matrices have non-zero elements, while all the other elements are zero. Well, set square matrices where all the elements are zero, except for the elements in the principal diagonal, are called diagonal matrices. Even this little square matrix with only one row and one column will be a diagonal matrix, as it doesn't have any other element. Now, let's play a small game of spot the difference. Can you figure out the difference between these two sets of diagonal matrices? Here, all the elements of the principal diagonal are non-zero but different, whereas the elements in the principal diagonal of these matrices, although being non-zero, are the same. A matrix where all the elements along the main diagonal are the same or equal is a special kind of diagonal matrix. We call it a scalar matrix. And when we say same and equal, we mean the elements have the same sign as well as the same magnitude. Keep this in mind. Here's another interesting fact. If I replace the elements in the primary diagonal with 1, it will still be a scalar matrix. But there's a catch. Suppose we do replace all the elements on the primary diagonal with 1. In that case, we'll turn our scalar matrix into another type of matrix called a unity or an identity matrix. And this matrix will always be denoted by a capital I. To specify the order of a unit matrix, we use a subscript like this. Also, if you think about it, a unit matrix will always be a square matrix with an equal number of rows and columns. That is why only one number is used in the subscript, which represents both the number of rows and the number of columns. Now, there's another kind of matrix that we should be aware of. It's a matrix that is similar to my bank account, just full of zeros. It doesn't matter if the matrix is a square or a rectangle matrix. If all the elements of a matrix are zero, then such a matrix is called a zero or a null matrix, and it's denoted with a capital O. With this, we conclude our conversation on the different types of matrices. But there's still a lot more interesting matrix-related stuff that will be explored in the later lectures. So, see you then.